Hello guys, so today we're gonna learn is binary tree. Okay, here you can see the binary tree. The prerequisites are that you must be know the binary tree, that what exactly it is, the theoretical concept, and we're gonna learn today the traversal part, that how to traverse on the binary tree. Just a theory, I'm not talking about the code, just for now the theory part. And how to traverse on the binary tree, it's just the answer is DFS, because all the three traversal that you might heard, pre-order and post-order and in-order, all they are considered within the DFS, that is depth first search. And there is another traversal, that is breadth first search, also called as a BFS. So there are types, that is I just told you, that pre, post and in order. And there are types of approaches, that naive approach and optimal approach. So I will be just giving you the glance of theory, that what are the types, and in the approaches, that you can go with the iterative way or recursive way also in the code, not here in the theory, because theory is just same for everything. So okay, now here are the types. So it's just theory. Okay, so here are the types. Now the words are highlighted, pre, in, post. Why it's highlighted? Because the pre, these words are actually, the words in the red color are actually showing the position of our root in left and right traversal. So how they are showing the position, if you are focusing on these words, then the words itself is saying the meaning. Okay, so here is the meaning. Like if you would be focusing on pre, then pre is means the root is in the beginning, and as you can see, the right and left and right basically are traversed later. Okay, I will be showing you the traversal just with the example. And now in this second one, the in order, the in means it's in between the right and left, that as you can see, yeah, that root is in between the right and left and right node and traversed. And here in the third part, here the post is saying that if once you traversed left and right children's or nodes into the tree, like here as you can see, the tree is, I'm taking one, I don't know what to call, but yeah, if you would be having the two children's, and then you will be needed to iterate on these two children first, and then later on you can traverse on this part. Like let's take an example, 1 2 3. If this is a tree, then the post order will be saying traverse the 2, and then this right 3, and then the root 1. So this will be 2, this will be 3, this will be 1. So the traversal will be something like 2 3 1, 2 3 1. ये here ऐसे जाएगा कुछ. Okay, so now we will be seeing the approach, just the theory. Here you can see there are naive approach and optimal approach, and naive approach actually consists two ways, that is recursive and iterative. Okay, the recursive is the simplest way, where you might be seeing the 3 lines of code, and there would be a base condition and 2 line of recursive one line will be visiting the node, and rest of the 2 lines will be having the recursive function. And in the iterative way, you will be using the stack, because stack is the core data structure required to traverse in traverse for the DFS, depth first search. And here in the optimal approach, that why is it optimal approach called as a optimal? Because it will be reducing the time complexity of traversal. Okay, so there is a option for the Morris traversal that will be helping us to reduce the time complexity of traversal on any of the DFS type, that is pre, post, pre-in and post. Why I am making it in the sequence? Because it's easier to remember. Pre means in the beginning, in means in between, and then post. So that's why I am try to write in the sequence as possible as I can. Okay, so here the intuition. Okay, let's take the example now. For example, let's first we will be doing the pre-order traversal. So what does pre-order traversal says? The root, the word pre, that will be referring to the position of root, and then root, then left, and then right. Okay, इसी writing अच्छी नहीं है. Pre-order and root, then left, and then right. Okay, so oops, okay, so here first this is the root. Okay, so we will visit it. Okay, so we just visited in the root part. Now what the question says, the root will be having those left and then right. So if this is root for now, so this is the left part of the root and this is the right part of the root. So one had already visited, so now the root will go in the left part. So now this will become root, and this 4 and 5 will become the left and right. So now once it become root, so we will visit it 2, then 2 will be visited. So here the 2 will be visited. Okay, now once the 2 is visited, the 4 will become root. Okay, now because it doesn't have left and right, as you can see, so once the 4 is visited, and before that it was the root and left and right. So once the whole right part had been visited, then we can traverse on the right part. So once the 4 is visited, now you can visit in the 5 part, this 5 node. So this 4 and then 5. Okay, so now as you can see, the whole these left tree, you can call it as a left tree, and this is the right tree, because the whole left tree and the root already has been visited. Okay, and here you can call it as a left tree, because you need to be seeing that what are the nodes here. So 2, 4, 5 are already been visited, 1 is already been visited in the beginning. Now the left part will become, so now 3, because right now 3 is root, so 3 will become added or visited here. So here we will add 3. Once the 3 is added, its root So it does have the two children's 6 and 7. So left part will be visited. Here you can see 6, and then right part, as according to the this pre-order traversal, the right part will be visited 7. So here we will be taking 6 and 7. So your whole answer would be like this. Okay, so 1 2 4 3 6 7. Here I will be showing, I want to show that 1 and then 2 and then 4, but here then 5, and then here 3, and then 6 will be traversing, then 7 would be traversing, as you can see. Okay, so this is how it works. Now we will be needed to do the in order and post order also. So I'm putting it over here. Okay, now in order, basically in order, which says the left and then root and then right. So first we have to see the left, but it's not, it's root already, so we cannot go with the root first. We have to go on the left part. Okay, so because this is again the root, it will become root, and this is not the left part. Once the 4 reaches, the 4 is again the root, we cannot go. We can go, but because it's null, so once the null will be, because null cannot be visited, so it's cannot be visited. Now the root that we all know, after the left node traversing on the left node, we will be reaching to the root node. So 4 will be added here, and once the 4 is added, now you can see there is no right. As you can see, the right node of the root must be traversed after the root node. So because there is no right of this particular root node, so we will be traversing again back to 2. So after the 4, the 2 would be visited, and then after that 5 would be visited. Why? Because the root have the right part, that is 5. So 5 would be visited. Okay, so once the whole left tree have been visited, as you can see 4 2 5 has been visited, now you can traverse on this is, as you can see, it's a left tree, and that's the left part of this root, that is 1. This is left part. Oh, बहुत ज़्यादा arrows हो गए. Anyways, so the left tree says 4 2 5. So 4 and then 2 and then 5. Okay, now the root is 1, so 1 would be visited because it's the root. Okay, so 1 just visit it. Now we have to traverse on the right part because it's root right now, and it's right tree of our whole tree. So now the 3 becomes root, and it does have the left part. We have to traverse the left part first, so we will be storing 6. Okay, 6 will be visited here. Now the root, because it's left and right, as you can see, left then root and then right, because according to the Inorder Traversal, left then root and then right. Left, that is 6, then root 3, then right 7. Okay, so 6 3, 7. That would be the order. Here you can see the 1, because 1 is already a route, so we cannot traverse on it. So first, after reaching 1 and then 2, so we would be having the 4 will be first, and then 2 would be second node of the traversal, and then 5 would be third node of traverse, and then it would reach in the 1, and then again 1, no, 4, 2, and then 5, and then here it comes in the 6 node, and then 3, and then 7. So this is how the traverse would be showing. Okay, so now we are done with the in order. In the same way, we can have the pre-order traversal. I know the video is a bit longer, but post-order. Now what does the post-order says? Post-order, the word itself is saying post. That means all the children would be visited left and right, then we can traverse on the route part. So here you can see that okay, this is a route itself. Now 2 is another route itself in itself. इसको थोड़ा से okay. This is much cleaner. Now, because this is a route in itself, this is again a route in itself, so this is again a route in itself, then now the left and right part must be visited. For now, route is this. Now it does have left and right. Okay, so what will be visited first? The left, that is 4. Now the right part will be visited, that is 5, this right, and now the route will be visited, that is 2. So this part is done, that is route, right, route. Now this, for this route, this is left and this is right. Now once the right is done, now we have to traverse on the left part. So what we have? 4, 5 and 2. Okay, so now the left part is done, that is left part, and now right part needs to be done, that is this is the right part. Okay, so right part already have the 3, that is route. So 6 is the left route, 6 is the left, and 7 is the right. So now you have to traverse on the 6, that is left. Now right, that is 7. Now route, that is 3. Left, right, route. As you can see here, कुछ ज़्यादा ही तारे जोड़ रहा हूँ. Anyways, this right part is again done. So 6, 7, 3. Now remaining part, left part is done, right part of the tree is done. Now the root is just remaining, so just add it 1. So these 3 are the 3 traversal of the way DFS traversals of tree. For now, there is nothing new, but yeah. So that's all for. Thank you for watching.